Hi, welcome back. Now we have to discuss some other constant values. One of the most widely used constant parameter is velocity of light. Velocity of light, which is denoted by c. This is equal to, we can write here, 3 into 10 to the power of 8 meters per second. Right? This is also one of the standard value. 3 into 10 to the power of 8 meters per second. And one more value also there, that is permittivity. This is also one of the standard constant parameter which is used in electric field. It is denoted as like this, epsilon. Right? This epsilon is equal to, we can write epsilon naught into epsilon r. Epsilon naught into epsilon r. Epsilon naught is absolute permittivity. Absolute permittivity, this is epsilon naught, and this value is a constant value. This is a fixed value. That value is 8.854 into 10 to the power of minus 12 farads per meter. So in terms of meters, this value is 10 to the power of minus 12, and if you want to write in terms of centimeters, this value becomes now 8.854 into 10 to the power of minus 14. 10 to the power of minus 14 farads per centimeters. So this is also one of the constant parameter we have to use in electric field. And another is relative permittivity. Relative permittivity is epsilon r. This is equal to 1 in free space. This value is 1 in free space, and depends on the medium, this value will change. So this value is completely depends on the medium, but absolute permittivity is a constant value. It is a constant parameter. That value is 8.854 into 10 to the power of minus 12 farads per meter. Right? And in this subject again we have to use some other decimal representations. Right? So those representations are like this. One word we are using internally, one is kilo. Okay, kilo is denoted as capital K, kilo. This value is 10 to the power of 3. And another word also we are using here, that is mega. So wherever the mega is used or capital M is defined, then we have to write 10 to the power of 6. Right? And another parameter is giga. Giga is denoted as capital G, and this value is 10 to the power of 9. Right? And one more also used in this one, that is tera. So wherever the tera word is used or capital T is defined, then we have to assume that value is 10 to the power of 12. So these are the standard positive 10 to the power, decimal positive power values. So kilo, mega, giga and tera, and these values are denoted as with capital letters, denoted by capital letters. And similarly, negative power values also there. So those are centi. So wherever the centi representation is used, and generally we have to write in terms of small letters, all the negative power values, 10 power negative values are defined in denoted by the small letters, right? So centi equivalent value is 10 to the power of minus 2. And milli, this is a milli denoted as small m, and this value becomes 10 to the power of minus 3. And one more also there, that is micro denoted by mu, this one mu, and this value is 10 to the power of minus 6. Right? And another is nano denoted as eta, this small n like this. Right? This value is 10 to the power of minus 9. And pico denoted by capital small p, right, denoted by p, and this value is 10 to the power of minus 12. 10 to the power of minus 12. So these are enough. So these are comes under negative powers, right? And some other parameters also we are using here, some other constant values representation. And temperature measurement purpose, we have to use per degree Celsius or per degree Kelvins, these two representations. So here I wrote like this, per degree Celsius. So wherever the symbol is there, we have to assume that is defined in terms of per degree Celsius, and this explains the degree Kelvins. Okay, so if you want to convert one temperature from x degrees Celsius to in terms of kelvins, then it is added by the 273. So this formula is used, 273 plus x degree kelvins. So this formula is used to convert centigrade to kelvins or Celsius to kelvins. Okay, the conversion from centigrade to kelvins purpose, we have to use this formula, 273 plus the centigrade value here, whatever the value, write that value directly here. And similarly, if you want to convert centigrade to the foreign heats, or Celsius to foreign heats, again we have to use another formula. The formula is like this. So the temperature is defined like this: x degree Celsius is equal to 32 plus 9 by 5 x degree Fahrenheit. So this formula is used to convert Celsius to Fahrenheit, and the first one, this one is used to convert Celsius to Kelvin. So these two also used within the subject. So just try to remember these formulas. Now here I want to write a simple table, because the standard values we are using in this, one value is at 0 degrees, and another is at like at room temperature. So we should know those values. So that purpose here I am writing few values in terms of centigrades and equivalent kelvins here, right? So in terms of kelvins, if the value is 0, so 0 degree kelvins, in terms of centigrades, this becomes now minus 273 degrees Celsius or centigrades. So just now explain this formula. From this formula we can write all this now, right? And one more, 0 degrees Celsius. 0 degrees Celsius is equal to, here it becomes 273 degree kelvins. 273 degree kelvins. And another standard value we are using, that standard value, this is one of the very, very important value, room temperature value. So wherever the room temperature word is used, immediately we have to take that value is a 27 degrees Celsius. Okay, room temperature in terms of Celsius is 27 degrees Celsius, but in terms of kelvins, that should be 300 degree kelvins. Okay, so because centigrade to kelvins conversion purpose, this formula is used. 273 plus 27 becomes here 300 degree kelvins. So room temperature, wherever the room temperature word is there, then immediately we have to take that value is in terms of Celsius 27 degrees, and in terms of kelvins 300 degree kelvins. So these standard values we have to use within the subject. That's why I wrote these values here. So please take this.